Okay, here we would discuss in this video properties of 9 as they relate to digit sum. This is video number 5, part 3 of 3. I split the video in 3 parts. This is the last part, part 3. In this video, you would learn about results checking using a digit sum. Okay, so by using this mechanism, student can discard out some of the options from a multiple choice question and simplify the problem so that student has left with a fewer option, most likely one or preferably one, and that's the correct answer. Okay, so we discuss problems using addition, for subtraction, multiplication, and division. The video discusses that result checking for a division is involved. It's indirect and suggests that you should look for another option if there is one. Other than that, digit sum check option does exist. Let's continue. Okay, let's continue with next section here. We'll talk about results checking with digit sum. Okay, let's continue here. In this section, you will learn how to eliminate some of the options in a multiple choice questions. Okay, see what we are talking about. Digit sum check allows the students to discard some of the options in a multiple choice question. And the digit sum check of an option does not confirm that option is wrong. Okay, if the digit sum of an option does not confirm that option is wrong, so you can use this sentence here to discard some of the options. Let's continue here. And let's look at some example. Original problem is 2683 plus 1453. Let's add them together. And the result I have is 4136. Okay, so add them together. And I get a 4136. Okay, you can do that too. Okay, let's continue. And digit sum of 4136 is 5. Okay, 3 and 6 add up to 9. You can discard that, cast that out, and so 4136 is a 41, 4 plus 1 is 5. Okay, let's do a digit sum version of this then. Okay, so we'll take a digit sum of 2683, which is 1. Here again 6 and 3 make it 10, make it 9, and we cast those out. 2 plus 8, 10, 10, and 10 digit sum of 10 is 1. Okay, next same thing here. Next digit sum of that number is 4. Okay, plus 4, which is digit sum of 1453. Now add these smaller numbers here, and that's a 5. So this 5 and this 5 match. So digit sum matches, or digit sum confirms. So this answer here is probably right. But before you say it's right or wrong, you should actually check for sanity checks on this thing. Okay, first thing is number of digits on the first line is 4, number of digits on second line is 4, and 2 plus 1 is not close to 9. Okay, so this is nearly 4 digits. So 4 digits, that's one check. And second check is this digit here, leftmost, need to be at least equal to some of the leftmost digit. 2 plus 1 and maybe more, maybe one more. 2 plus 1 is 3 and it's a 4. So that checks. On the rightmost, right digit plus right digit is a 6, and that checks. So you need to do some digit sums. Some digit sum would give you some idea that this answer is either wrong or probably right, and you do some more sanity checks to confirm your answer. Okay, let's continue here. Digit sums confirm and answer is probably correct. Okay, here now this time we'll do a 41862 plus 57154. It is a 5 digits plus 5 digits. Okay, and answer I got is 98916. Okay, okay, let's continue here. A digit sum of 98916 is 6. Okay, let's do a digit sum version of the same thing. So digit sum version, first number is 3. 3 is a digit sum of 41862 plus 4, which is digit sum of 57154, and Add these two smaller numbers together, it's 7. 7 and 6 do not match, so digit sum does not conform. So this answer is wrong. This answer is wrong, and you can eliminate that option from the multiple choices. Okay, let's continue. Digit sums do not conform, and this option for 9896 is not correct. Example here for addition here. This time I'm going to add 81064 plus 21201. Okay, let's see the answer. One of the options I'm using here is 102256. That's the option, one of the options. Okay, let's digit sum of this number is 102256 is 7. Okay, let's continue. Okay, let's do digit sum version of the same problem. Digit sum version is digit sum of first number is 1. Okay, digit sum of next number is 6. One add two smaller numbers together, 1 plus 6 is 7. So this one and this one matches, so digit sum conforms. This is probably correct. But let's go take a look and do some sanity checks here. Okay, first 5 digits here and 5 digits here. Okay, okay, let's eliminate for a while this last 4 digits and do this 8 plus 2 10. So this is probably correct. Okay, last leftmost digit plus leftmost digit is 8 plus 2 is 10. We have a 10 here, which is to the left of 4 digits. Okay, now let's do the rightmost now. 4 plus 1 is 5 and have a 6. So that doesn't match here. So that means digit sum say this is probably correct, but this in fact is not correct. Okay, okay, let's digit sums confirm. The option for 102256 is probably correct and is in fact incorrect. Actually, correct answer is 102265, where 5 and 6 are to be replaced. That also would confirm the digit sum, and that would be the correct option. So, if this is an option for this problem, another option must be 102265. That also would confirm, and that would be correct answer. Okay, let's continue here. Let's do a digit sum checking for subtraction problem. Our problem is 87083 minus 22289. Let's continue. And one of the option is 64794. Okay, let's continue. Digit sum of this thing is 64794 is 3. Okay, let's do a digit sum version of this the same problem. Okay, digit sum of first number is 8, so 8 minus 5. Digit sum of the second number is 5. Let's do the subtraction here. 8 minus 5, 3. This 3 and this 3 matches, so digit sum confirms this option. So that means this option is probably correct. Okay. Let's continue with the multiplication problem here. We do multiplication of 23 times 34. Okay, one of the option is 782. Okay, so digit sum of 782 is 8. Okay, let's do a digit sum version of the same problem. Digit sum version, digit sum of 23, first number is 5. Okay, of the next number is 7. 5 times 7 is 35. Do a digit sum of that. Digit sum of 35 is 8, and 8 and 8 match. That means digit sum confirms the option 782, and that means 782 is probably correct. Okay, let's continue here. Digit sum confirms the option. The option is probably correct. We say probably correct because this is just a necessary condition on not a sufficient condition. We have already seen that when digit sums matched, the option was, one of the options was incorrect. Let's continue. Let's do an example for division. Problem I'm going to select is 67 divided by 13, and one of the options is 5, remainder 2. Okay, and digit sum checking for division is indirect and involved, but let's go ahead and see we can still do it. So let me identify the terms. Dividend is 67, I call DD. Divisor is 13. This is 13. I call dr. Divisor is dr equal 13. Okay. And quotient is this term here 5, and I call q is 5. Remainder is this term here 2. I call r. Remainder is 2. Okay, let's continue here. Let's try to do a check somehow. So in a division problem, if q is the quotient, r is the remainder of dividing dividend by dr, then this equation must be true. Okay, so that means 67 must be equal to 5 times 13 plus 2. Now we apply the digit sum check to this equation here. 67 is 5 times 13 plus 2. Okay, left. So digit sum of left hand side is 4. Digit sum of right side is digit sum 5 times digit sum of 13 plus 2, which is equal to digit sum of 22, which is equal to 4. That means digit sum of left side is true 4. Digit sum of right side is 4. That means the left side and the digit sum confirms. So this is probably correct. But let's say you should actually try to do establish the correctness of this equation here, which is a lot easier, at least in this problem. Right side is 5 times 13, 65, plus 2, 67. So this match, this actually is correct. 5R2 is in fact correct, and you did not have to go through digit sum. But for a division problem, is you can go through digit sum check, which is indirect, but if there is another option to check, you should use that. Okay, let's continue here. So this match and digit sum is confirmed. The option is probably correct, and I don't have not included any problem sets for you. Just use the teacher's manual for example problems. Okay. Okay, teacher manual is my main reference, and here you can find ideas for more patterns from Vedic Square, and also can find problems for checking the results using digit sum. Tirthaji does not have a section on digit sum, and I have not seen digit sum being used in the book. Okay? Both Glover and Vanna Singhal call this digit sum by use the term digital root. Bhatia writes books on competitions. That means he is very good at multiple choice problems, and he is keen on using digit sum to eliminate some of the options.